right, my friends, let's see how it went here. Starting with part A. Let's take a look. Okay, so no need to complete the square on part A because it's already done for you there on the right side. So whatever you do, do not expand y minus 3 out. Don't square that out, okay? Leave it like that. But in order for me to tell how this one is shifted horizontally, I'm going to need to factor the coefficient of x out. Remember that your horizontal shifting rules only work if your coefficient of x is positive 1. Okay, same thing for y. So you need a positive 1 here, and then you need x to have a positive 1 for its coefficient. Okay, so let's factor negative 2 out. So negative 2 would need to be multiplied by x minus 2 to get that expression kind of back when you distribute it in. And then I'm just going to bring the y minus 3 quantity squared down. Okay. All right, next, remember, the way that we've been trained makes us really like your stretch factors to be on the squared term side. So for that reason, you're going to see me divide both sides by negative 2. So then I'd have x minus 2, kind of, this is a bit redundant, but kind of to the first power, and then equals negative 1/2 times y minus 3 to the second power. And this is where you'll probably start liking the way that we think about horizontal shifting rules if you haven't started liking it yet. So you can see that x minus 2 is inside a function there. And so you could tell that the graph would be shifted to the right 2 units. And then we're subtracting a positive 3 from y inside the function. So you tell our graph would be shifted up 3 units. So the vertex of this thing should be at the point 2, 3. All right, hopefully that part makes sense with the horizontal shifting rules. Next, what is your parent function? At its core, if you were to strip off all of the vertical and horizontal shifts, and then strip off that stretch factor, really at the core, we're looking at an x equals y squared graph. And then furthermore, so you know it's going to either open to the right or to the left simply because that's the parent function. And then if you kind of consider, in addition to that, the fact that you have that stretch factor of 1/2 and you have it also, it's also negative, then you could tell which way it's going to open. Did I write that funny? Yes, I did. There we go. All right, you can tell which way it's going to open. It should open to the left because you have that negative there, and then you should have a stretch factor of 1/2. So we're going to go up or down 1 from the vertex, and then to the left 1/2 a unit. Again, started the vertex, up or down 2. Instead of going to the left 4, we're going to go to the left just half as far. There we go, so just 2 units. And then, you could do more accuracy if you want. But I'm going to go ahead and fill it in. Let's try not to make it look pointy at the vertex. There we go. All right, my friends, hopefully that makes sense. Okay, now for part B, I hope it makes sense. This is going to be an x equals y squared parent function. But before we can figure out how it's shifted, we're going to need to complete the square on the right side. Oops. Okay, so factor out the leading coefficient, which is negative 2, and only factor it out of the y terms. So negative 2 times y squared, and then positive 4y. What are we going to do with the constant term? We're going to kick it out. It's for everyone's own good. All right, next you're going to look at your linear coefficient there, which is a 4. You're going to divide it by 2. You get 2, but then square the result, and that will tell you this magic ingredient that should go here for a perfect square factoring in the next step. Now be careful, you can't just add 4 and think that that's okay. But in addition to that, we didn't just add 4. We actually just, subtracted 8, right? Negative 2 times 4, negative 8. So we're going to add 8. On to kind of make it so we just added a fancy version of 0. So make sure that when you put this magic ingredient in, you pay attention to how much did you just change that side of the equation, and then undo the change on the outside of the parentheses. All right, next, factor the trinomial as a perfect square binomial. And then combine like terms on the outside. Negative 5 plus 8 is 3. There we go. And then I'm just going to subtract the 3 over. So I'd have x minus 3 kind of technically to the first power, and then equals 2 times y plus 2 squared. So let's pay attention to our horizontal shifting rules. So this would be shifted to the right 3 units and then down 2. So the vertex should be at the point 3, -2. Which way should it open? Well, if you stripped off the shifts, you'd be left with x equals -2y squared. So you've got an x equals y squared parabola, but so it would open horizontally. It'll open to the left since your coefficient is negative, and you have a stretch factor of 2. So up or down 1, to the left 2 from the vertex, up or down 2 from the vertex, and then normally you'd go 2 squared, which is 4, but we're going to have to go double that, so we're going to go 8. So let's see, so that would put you at 5. And then we do the same thing when you go up. There you go, and then fill it in. Oh. There we go, my friends. All right, that is it for section 9.1 part 1. At this point, I hope you feel comfortable with graphing either a y equals x squared parabola as a parent function or an x equals y squared parabola. I hope you're okay with the new way of thinking of shifting rules. It should give you the same answer as what we would have gotten using the old way of thinking. That you know that stretch factors, the way we think, has us putting them on the squared term side. Yeah, and to be able to tell when a parabola would open to the right, to the left, or up or down. All right, my friends, in the next section, it gets even more interesting. So hopefully you got this foundation set so you can learn a lot more about parabolas in the next lesson. Take care, everybody.